Hello, 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 everybody, and welcome back. We're looking in this video at question 23 now from our 2019 Fermat. How many positive integers n with n less than or equal to 100 can be expressed as the sum of 4 or more consecutive positive integers? Oh, positive integers. All right, now that throws a little bit of a wrinkle into it. For example, let's see, something like 2 can be written as the sum of 4 integers, 2 plus 1 plus 0 plus minus 1. But you have some non-positive things going on there, so that causes a bit of an issue. What's the best approach? So one thing we could try and do is develop a little theory. What sort of numbers can be written as sums of consecutive numbers, and then sort of adjust things with positive to account for this positivity. But we're a little constrained here. We've got the numbers up to 100. So we don't actually care if, for example, 153 can be written as a sum of 3 consecutive numbers, which I believe it can. And so we might be better served, rather than trying to develop a whole bunch of theory, maybe just trying to see, can we notice enough patterns to deal with the first 100 numbers? Now we want 4 or more consecutive positive numbers. So let's just say we took a look at 4 consecutive positive numbers. The smallest you can have would be 10. 1, 2 plus 2 plus 3 plus 4. That's 4 positive numbers, the 4 smallest positive consecutive numbers, and that adds up to 10, right? So, 9 is not going to be something I would put on my list, or 8, or 5, or anything like that. Now, if we were just sticking with only sums of 4 consecutive positive numbers, what would be the next one? Well, you get rid of the 1. You sort of shift everything over, and you introduce a 5. So 2 plus 3 plus 4 plus 5, this is going to be 14. And so, ordinarily, if this were up to something like 1,000, or possibly even something like 200, I might not do this sort of approach, but this doesn't seem to be that bad. And you might also notice there's a little bit of a pattern forming here. We're going up by 4s. Now, you might not see that right away. It might take you a moment to work that out, but you do actually jump up by 4s here. And more generally, if I've got sort of the sum of of k, so the sum of k consecutive positive integers, and we'll call that, I don't know, capital N. If I were then to sort of add 1 to every number, and get the next k consecutive numbers, well, I've added a 1 to every single number. How many numbers did I have? I was adding k of them. Up here we're adding 4 of them. So I've added k ones. I've plus 1 k times. And so you should get the next number you would get would be n plus k. That's why we go up by 4s here. If I were to do 1 plus 2 plus 3 plus 4 plus 5, 15, I know the next one's going to be 20. I don't actually have to write it out. Okay, but you can check. 2 plus 3 is 5, plus another 5 is 10, plus 4 and 6 is another 10, makes 20. So that suggests to me that perhaps something we might try and do is what I'm going to do. I'm gonna write out. Yeah, ordinarily I wouldn't do this exactly. Well, actually I might. I'm going to write out all the numbers from 1 up to 100. We probably don't need the first up to 10. I'm having trouble writing this. Okay, let's 51, 61. Got to remember to leave a little bit of space at the end as well. 81, 91, 92. Maybe I should just stick to going horizontal because I keep messing my numbers up. 22, 23. But I'm going to create sort of like a sieve that you may have seen the first time you were introduced to prime numbers. And then we're just going to sort of keep track of, here's essentially what I'm going to do. 10, I know, is a sum of 4 consecutive numbers, and then I can just very easily count up by 4s. I don't have to put a lot of thought into what I'm doing, and then at the end I'll just sort of count the numbers that have been circled. That's my strategy here. Is it necessarily the most efficient? Well, no, you could probably do some other things, but I'm trying to avoid developing a whole lot of theory, because it's not like we're working with a particular sort of fixed number where we could work with some factors or anything like that, which you can see in other questions. Okay, 63, 73, 83, 93, 94, 95, 96, 97. I do admit I am sort of wasting a bit of time writing these all out. Whereas you could probably start off going 10, 14, 18. In fact, you could probably do this with some inequalities, but I figure I've got a video, I can do this in a nice visual format for you. '80, 70, 69, 66, 68, 67, 77, 76, 78, 79. Okay. So there we go. And now I'm going to count up by 4s. And all of these that I'm working with, notice we're sort of jumping up by 20 so we can notice more patterns and fill this in even faster. So this will give me all the numbers that can be written as a sum of 4 consecutive positive integers. But this way I don't have to worry about trying to find any overlaps. If I were to just sort of write out all the possible lists for 4 and then move on to 5, I'd have to say, okay, well, I got, I don't know how many we got in this list. 5, and then another 5, and then another 5. Another 5, and then only 2 in there. So it looks like we got 23. So, I got 23 here, and then it looks like I've got, I don't know, 17. I don't know if that's the actual number. We'll find out in a moment. But, some of these are on this list and also on this list. I don't have to worry about that. I'm just going to circle as I go. Now, what's the smallest sum of 5 consecutive numbers? 15. And then we go up by 5s. So you can see 30 would be on both lists. 50, 70, 90. These are on both lists. Okay? Oh, and do we want less than or less than or equal? Less than or equal. So 100 counts. So 100 is actually 18 plus 19 plus 20 plus 21 plus 22. Okay? Now, what's the smallest sum of 6 integers? Well, it'd be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So we take this 15, our lowest one there, and we just add 6 to it. And then you keep adding 6 from there on out. So 27 goes to 33, goes to 39, goes to 45. 45 should be the sum of 6 consecutive numbers. It'll be 5 plus 6 plus 7 plus 8 plus 9 plus 10. Yeah, that's 3 15s. And we'll get 51 here and 57. So already I'm starting to repeat again. So it looks like we're going up by 30 each time. And 75, and it looks like that's it. There we go. So that's, 2, 4, 6, 8, 10, 12, 14 more. And then, okay, now I want sums of 7 consecutive positive integers. So I take the 21, my lowest with 6, I add 7 onto it, and then I keep going up by 7s from here. So 35, the next one would be 42. And it looks like these are just multiples of 7, so I can go through them fairly quickly. There we go, 70, 77, 84, 91, and 98, which again was already on another list. And so we can just sort of keep going through this. Now the sum of 8, so that would be starting with 36, and then go up by 8s each time. So that'd be 44, 52. Looks like we'll just go back 2 and down by 1. So 60, 68. And it might be a good time, every once in a while, just double check, am I really getting something? Is 92 really the sum of 8 consecutive numbers? And just a quick little double check to make sure you are circling the right numbers after going through this whole process. All right, sum of 9 consecutive numbers. Start with 45, because that's 1 plus 2 plus 3 all the way up to 9. And then just go up by 9s. You notice I'm circling a lot that have already been circled. 72 here. For example, that would be 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14. Should be that one. Is it? Yeah, because 9's got to be in the middle, right? No, if I want 8 should be in the middle, and there should be 4 numbers before it and 4 numbers after it. So 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. And then the 4 and the 12 pair up to be 16, 16, 16, 16. That gets you up to 64, plus the 8 in the middle. Okay. Yeah. 81, 90 is the sum of 9 consecutive numbers, and 99, which has already been circled. Sum of 10 consecutive numbers, and you notice the smallest one that we're getting is decreasing. Is increasing each time, so we're getting less and less numbers. Going up by 10s is pretty easy there. 66 for the 11s. And go up by 11 each time, that'll be 77, 88, 99. And then 12s. So from 66, then we go to 78. That's the lowest that can be written as a sum of 12 positive integers. So 78, and then add 12, you'll get 90, and then, well, you can't go any further, okay? Because then you get 102. And then, we are really running out of colors here. So from 78, you go to 91, and there aren't any more that are the sum of 13 consecutive positive integers, and then if you were to add 14, you get beyond 100, so that's it. So now we just count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 50, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63 should be our answer. And so we'll say 63 numbers can work like this. The only reason I use this sieve method, again, is because we're sort of limited in the ends that we're talking about. So I'm going to say my answer is B, 63. All right, there we go. Up next, we've got only 2 more questions left to go on this Fermat paper. Up next, question 24. I'll see you for that next time.